Hi, Mike. Thanks for your time today. I was hoping you could introduce yourself and PolyScience.
I am Mike Gallagher. I am an OEM Account Manager at PolyScience, which basically means that I handle clientele like David who use our equipment along with their systems to facilitate cooling. I've been in this industry for off and on 25 years, and we are an American manufacturer based right outside of Chicago in Niles, Illinois.
Very good. Most of the organomation customers that benefit from using your recirculating chillers are the environmental laboratories who are doing large scale solvent removal, typically samples held in 250 ml flasks. In these applications, you're evaporating excess solvent and then through a concentration tube recapturing the solvent. Obviously, this has a lot of environmental benefits because the solvent isn't going up out of the fume hood and into the environment. I was hoping you could talk a little bit about the common applications that can benefit from chillers.
Evaporation and condensation is certainly one of the main things that people use our instrumentation for. The applications for our type of equipment can be many and varied. One of the main ones is, and certainly something that I personally get involved with a lot, is original equipment manufacturers will use our chillers in conjunction with their instruments to maintain temperature because of a lot of analytical instruments they require a very precise control of the temperature of the sample being analyzed. So that's where we come in. We help to maintain those precise temperatures so that the instruments get repeatable results from time to time. So everything's accurate, it's reliable, and it's repeatable. Another common application is chemical reactions, which customers will use either a borosilicate glass or a stainless steel reaction vessel. And what they need to do is control the temperature. These are typically have a water jacket around them, which is where we come in. So we maintain the temperature of that water jacket so that they, again, can get reproducible results. It also helps in the case of combining different chemicals if they result in an exothermic reaction, which will increase the temperature of the vessel. The chiller then will help bring that temperature back down to be able to remove that excess heat. Also, of course, really big, what people use our instruments for is to cool down and keep biological samples at a precise temperature. This, of course, will prevent the degradation of those samples and ensures the viability of all of that material during the experiment and into its storage. Something I deal with to a lesser extent, but I do have customers in this industry, is the cooling of laser systems. Lasers, of course, generate a tremendous amount of heat. So without the removal of that heat, the laser wouldn't last very long in simple terms. So we help to, again, control the excess heat that's thrown off by the laser to keep it from damaging itself and overheating. Also, and probably maybe a lesser known application of ours is for the cooling of medical devices, such as hospital equipment, MRI machines, CT scanners, other diagnostic equipment like that, because it ensures, again, much like with a laser, the removal of heat from the system to keep the system from damaging itself and to extend its lifespan. Probably to get back to the first point, some of these analyzers could include viscometers, rheometers, mass spectrometers. In the petrochemical industry, particularly cloud and pour instruments, there are a myriad of ASTM standards that need to be analyzed in a reproducible way, and our equipment helps with that. Viscometry being one of them.
Very cool. I've really enjoyed our work together over the years. I believe you've been the only rep at PolyScience I've worked with.
Well,
But
David, I'm around
works.
forever, so I started
Yeah,
at
no, that was a long way of
I
saying
started at PolyScience in 2007, so it's been a while. We've had a good relationship for a while.
absolutely. Yeah, that was a long way of me saying I know I'm talking to the right guy. And I definitely appreciate all of your notes here. What are some of the common mistakes or oversights a laboratory could make when they're evaluating a chiller
I
purchase?
People underestimate how much cooling capacity they need, and that people don't necessarily understand that the lower you go in temperature, the less power you have to cool. If you're trying to condense, particularly in your case, it's important because there's a lot of a difference if I'm trying to condense something at, say, 15 C if the solvent can handle that, or if I'm trying to condense it at 0 or even -5 or -10°C. I've got to make sure that I have adequate cooling capacity at that deep temperature, which is just because the chiller says on it, okay, I can cool 1,000 watts at 20°C. You're not going to get that at 0 or -10. You're going to get maybe 100, 200 watts, and that can affect how much solvent that you're pulling out. So in your case, that's extremely important to make sure. And I don't know that people differentiate. They just look at the one spec and don't think, well, now I want to condense at -5 or -10. That may not be optimal. Also, of course, the equipment that we sell varies in temperature range. Maybe you're buying it for a specific application in the beginning. Perhaps I want to do X. I think it's important to consider with this equipment the kind of versatility that you can get out of it if you buy something maybe with a slightly wider temperature range. Then I could do X, Y, and Z with it. So temperature range can affect that as well. But along with that is what type of coolant am I going to use? The line of Durachill chillers that you use, those are designed to primarily, in fact, really they're designed to be used with either a glycol water mixture or just plain water. We do have options for more different types of exotic fluids that could be used, deionized water, fluoriner. So we do offer that, but I think, and I'm not sure that everybody understands that if I have a recirculating chiller, I can't go dumping silicone oil into it or something exotic like that. It's just not designed for that type of coolant. Of course, something that sounds basic, which sometimes is overlooked, is where am I going to put this thing? Because anything that has a compressor in it is rather large. So, do I have room for this thing in my lab? It's also important to have adequate ventilation around it. Ideally, you want 6 to 10 inches on all 4 sides of the instrument, if it's air cooled, particularly, meaning that it's got a fan in it, and the fan is what's removing the heat that's generated by the condenser and the refrigeration system. So that's always a consideration. You also, I think that end users don't also understand this. These do have compressors in them and they have fans in them, so they're going to generate some noise. That being said, we've come up with a couple things with our chillers and our other instruments to mitigate that noise. The one is we've modulated how the fan works. So the fan will not run 100% of the time. The fan will only turn on when there's enough, it senses there's enough heat built up. Then the fan turns on and will remove that excess heat. Once the temperature is back where it should be, it shuts off. So that really does mitigate a lot of the noise. And depending on how hot the unit's getting, the fan may not run even when it's on 100% of the time. So that really cuts down on noise. Another thing we've done is our refrigeration systems are designed so that you can turn them on at higher temperatures, which basically what that means is the compressor is not running all the time, which also cuts down on a lot of the noise. So that's a lot less of an issue than it used to be. But that being said, I've been in some labs where some poor soul has the thing sitting right next to their desk, which I wouldn't want either, but not much we can do about that.
Oh, absolutely. I know there's different types of pumps. I was hoping you could talk about some of the differences
Sure, and
there.
that would vary by manufacturer. At
Mhm.
one point, we had 3 different types of pumps, the first being a mag drive centrifugal. The nice thing about those is they're very reliable, they're very quiet, but they don't have the pumping capacity to generate a lot of flow and pressure. The line of chillers that you're buying, we used to offer that, but we had very few people buy them because generally, if you're buying this type of chiller, you want a lot of flow and a lot of pressure. So we discontinued the mag drive centrifugal, but they're very good pumps, and we use those in our smaller line of circulators, and very few problems with those. They're pretty bulletproof and they're very reliable. They're also very quiet. The two things that we do still offer are a positive displacement pump and a turbine pump. From a
Mhm.
practical standpoint, they both do function in different ways. What I will say about positive displacement pumps is they are noisier than turbine pumps for sure. And they're more prone to needing to be maintained, and they have less of a lifespan than will a turbine pump. They're also not, from a cost perspective, they're not as expensive, but most of my customers, like yourself, will choose the turbine pump, and that's, I always think, a great option. And just for, in terms of its longevity, the noise generated, and the performance that you get out of it. And the performance in terms of flow and pressure between a positive displacement pump and a turbine pump are pretty similar. But in the end, if you're asking
Speaking,
me if I have my druthers, if I had to buy one, I would go with a turbine pump.
we've been thrilled with the reliability of the chillers that PolyScience has provided. All of our end users have very glowing reviews of the product. Speaking of longevity, would you mind getting into some of the critical maintenance practices that someone can do to maintain their chiller?
Absolutely. I would say you should reasonably expect with 8 hour use in a 5 day week, you should get 10 to 12 years out of one of these chillers. It's kind of interesting. We got a unit back and an email went around about it. And this unit was from, I think, the mid 1980s and it was still functioning up till now. So I would like to think that end user did a good job of maintaining these. But I think the most important thing is you keep the thing as clean as possible. And by that, you can do simple things, wiping down the exterior cabinet once in a while, just with a damp cloth. The one thing that's important is the filter that's in the front of the condenser. That's got to be cleaned at regular intervals. And I can get more into that because we've come up with a clever solution to make that more user friendly for the customers. I'm not even sure if you're aware of this, David. So, but I'll get into that later. But yeah, keeping that filter clean is a major thing. And also, the one thing that folks don't change the circulating fluid enough. But we've also come up with a clever solution to help mitigate some of the problems if people don't do that. But I would still say with average use, even with the technological advancement we've come up with, depending on how hard it's used, 60 to 90 days perhaps to clean that. And in addition, which probably few people do but wouldn't hurt, removing the side panels off of it and blowing it out with compressed air certainly couldn't hurt either. Obvious things, making sure that the fluid lines going to and from whatever it's hooked up to, that they're not cracked, that they're not developing cracks, because that will invariably form a leak, and then you'll have more of a mess on your hands than you really want. So, but I think the main thing is making sure that fluid is fresh, because that really can impact that, as well as a dirty filter can impact how the chiller performs. So yeah, those are the two main things I've found to be. And I like I said, I used to get into a lot of labs, and I've seen some less than ideal conditions, particularly in the petrochemical industry. It's just the nature of the beast of what they're dealing with. So, but I have seen performance affected by blocked air filters and old fluids. So those are my two big bugaboos, if you will.
Makes sense. And yeah, there's certainly similarities with what you talked about and what we see on the evaporator side with our water baths. The number one thing, keeping that bath water clean, would go a long way to preserving the instrument. And certainly we see that as well, visiting units that have been in the lab running without issue for decades.
Right. That's the goal.
Absolutely. And one thing that's always impressed me about PolyScience is that you're constantly innovating and improving the product. So I'd be happy to hear about any of the advancements that have been made in chillers recently.
Particularly in your line of chillers, we integrated into those a large full touchscreen display, which is really intuitive to use. I mean, if I don't have to read the operating manual to figure out how to use it, that's always a good thing. And from the first second I walked up to that, I'm like, okay, temperature pump. I mean, it is very intuitive. Also supports 5 languages: English, Spanish, French, German, and Mandarin. So that's also a very user friendly interface. One of the things I was mentioning from a maintenance standpoint that we came up with is what we call a dynamic filter. It's actually like a scroll in there that you can set for different time intervals to always make sure that when that scrolls, it moves a fresh piece of filter material in front of the condenser. So I think you can set that, if I'm not mistaken, at 30, 60, or 90-day intervals, perhaps even more choices than that. But that's one thing that makes it, you don't have to remember to pull out. I mean, you still could put a passive filter in there if the customer so choose, but it eliminates the fact that you have to think once a month, I better pull that passive filter out of there and run it underwater and let it dry out. Because I'll tell you what, David, I do have a room air conditioner in one of my windows, and I would be lying to you if I told you I took that out every 30 days and cleaned it out. So even I who should know better, just so that dynamic filter really helps from a maintenance standpoint. Another thing we did from a maintenance standpoint, which will prolong the fluid life, is there's now a UV light in the fluid path inside the filter. So that light is constantly on, and what that will do is any microbes or bacteria that builds up in there, it will kill them. In that case, with one of those in there, I would say you could get away with, depending on use, 90 days without changing the fluid, because that light really does do a very good job of keeping the fluid clean, which also eliminates the fact that you would have to put in a separate algicide or bacterial inhibiting agent. So again, from a maintenance and user friendly standpoint, that helps a lot. Also, what we've done in this line of chillers is they will now heat up to 70 degrees C without an additional option, which is good for an application like a laser, so that the chiller would have to be brought up to above ambient temperature before operation can begin. So the fact that we've extended that temperature range up really helps in an application like that. I mentioned before about the modulating of the fan, which is what we call whisper cool. So not only does that aid in noise reduction, it also, of course, uses less electricity that way if the fan's not running full bore the whole time. So we've found a way to make that more energy efficient too, along with something we call cool command, which is the ability of the compressor to come on at elevated temperatures. Like when I say elevated, I mean above ambient, above 30 C. If you demand for cooling at, say, 40 C, the compressor will come on at that temperature without already having to be on. In the past, the compressor would basically always run in order to be able to meet that demand at a higher temperature. But now it won't engage until it's actually called for. You've probably noticed that we've put the fill for the reservoir on the front of the unit, whereas before it was on the top. So that, again, if it's tucked in underneath a bench or somewhere, you don't have to pull the thing out in order to refill it. So I think that about does it for that. But I also did want to touch briefly on the changes that are coming in refrigerants. And you and I have discussed this briefly in the past. Due to European regulatory agencies, the EPA, they're always seeking to lower what's called the global warming potential of refrigerants. And that's been happening since the 1990s. And now it's getting to the point where these new refrigerants that they're going to come out with, they're very environmentally friendly. However, one of them, and one of the main ones we'll be using, which is called R290, that's actually a refrigeration grade propane. So one of the drawbacks to it is it's a great refrigerant. It does very well at that, but it's flammable. So we have already, knowing that we're going to have to go to this, which I think is by 2027. But we've set up our refrigeration assembly so that we can safely use those flammable refrigerants. Another one that we're looking to use is R513A for now. That's non-flammable, but that'll be a short-term use for that. And I forget what the one is that we're going to move on to next, but that will be, even though it's not as flammable as R290, it still would be classified as flammable. So that's why we've totally, even now, redid our production lines to be able to accommodate that, because it's coming and it will be much more environmentally friendly, and the refrigerants will have a much lower global warming potential than even the refrigerants being used now, which are a far cry from what was being used from when refrigerants became prevalent from the 1950s on. So those are just a few of the things that are coming, or that we've already implemented for that matter.
No, that's great to hear. Well, Mike, I really appreciate your time today and educating us on
My
chillers.
pleasure.
Uh, I look forward to seeing you in a few weeks, and we'll touch base then. And I look forward to seeing the new line of PolyScience chillers. Thanks so
Undoubtedly,
much.
if we can talk again on anything else, be happy to help.
Absolutely. Thanks, Mike.
Thank you, David. It was a pleasure.